So today our class is Computer Organization Module 4, Lecture 8. So last day we learned about the communication between the two different types of devices. Okay, the communication between different types of devices can be done in the three ways, as I have already discussed. Number one is the programmed I/O. Number two is the interrupt driven I/O, and number three is the DMA or direct memory access. Okay, this is the process of communication between the two devices. But you must remember that when two devices want to communicate, the communication is done through the bus. Okay, so buses are actually used for communication between the two devices in a system or in a computer. So there you know that there are mainly three types of buses in a system. They are the control bus, address bus, and the data bus. What is the function of control bus? Control bus actually transmits the signal from the CPU to the different types of devices. Address bus, you know, the function of the address bus is to transmit the address of the particular memory location or IO devices. And the data bus is actually the data is transferred from the one device to another device, or one component to another component. That is, it may be from memory to IO device to memory to register. In this way, data bus is used for communicating between the two types of devices. So there are mainly three types of buses. Okay, and using that bus, one particular component can connect with the another component in a system. This is called the bus communication. Clear? Now, for communication using the bus, there is a requirement of the control of the bus. Okay, that means last day we learned about how data can be transferred from the IO device to another device, but it can only pass it through the bus. Okay, so bus control is very much required for transmitting the data from one device to another device. Okay, when one component want to connect with another component using a bus, so there is a master and slave relation in the components. Okay, one particular unit acts as a bus master and supervises the use of the bus by the other units. These other units act as a slave. Okay, suppose in a computer, you know that CPU actually the one of the main components. So CPU acts as a bus master. Bus master means CPU can only control the bus. It can only grant the bus to the another device. You know that in case of the DMA, or you can take the bus from the another device, or it can give the bus or leave the bus for the another device when it is required. So CPU acts as a bus master. Okay, now memory and IO device actually acts as the slaves in the system. Clear? Now here IO controller may also act as a master. Master means which initiates the transfer to a bus. Clear? So in a system, CPU acts as a master and all the components act as a slave. Or IO controller, sometimes it is called DMA, may also act as a master. That means it can grant the bus to particular device, or it can take the bus from a particular device. So IO controller may also act as a master. Okay, in the system. Okay, so master, what is the function of master? Bus master. The function of the bus master is that bus master can only initiate the data transfer. Okay, no other components can start the data transfer. This is the only the master who can initiate the data transfer. Clear? Then slave only requests it. Suppose in the DMA, particular IO device or DMA controller requests the CPU. In this case, CPU is the bus master, that please leave the bus for me. When CPU leaves the bus, then DMA acts as the bus master, and DMA, according to the requirement of the IO device, DMA gives the access to the bus to a particular IO device. So in this case, when CPU is using the bus, CPU is the bus master, DMA or IO device is a slave. When DMA requests the bus from the CPU and the bus is granted, DMA is the bus master or IO controller is the bus master, and it can give access to the bus to the different IO units. So this is the bus master and slave in a system. Okay. Now, based on the bus transfer, you know that bus is actually used for transferring the data from one device to another device. Okay. Now, based on the timing of the data transfer, bus can be divided into two types. Okay. What is timing? I will tell later. They are called the synchronous bus, and another is called the asynchronous bus transfer. Again, I repeat, depending on the timing of the data transfer in a bus, there are two types of buses in the system. One is called the synchronous bus, another is called the asynchronous bus transfer. What happens in the synchronous? Synchronous means, always remember, that synchronous means that one clock is related with the transfer of the data. Clear? That means if the computer system clock is related with the transfer of the data, then that transfer of the data using the bus is called the synchronous bus transfer. Okay, that means related with the bus transfer, one clock related with the bus transfer means that one, according to the timing signal, the data is transferred from one device to the another device. Okay, if I give one example, it will be clear. Now, if I use the synchronous bus, there is a one disadvantage. Disadvantage is that data transfer rate are determined by the slowest unit in the system. Okay, that means what is the meaning of that? That means if I transfer the data from one device to another device using the clock, so CPU or the total system has to wait for the slower device because one clock is related with the particular system. Just like that, pipelining, you know, in the pipelining, for designing the pipelining, the timing or clock cycle timing depends on the particular hardware device in the pipelining. You know that what is the time period? Time period is maximum if there are four components, maximum of the time T1, T2, T3, T4. So that is the total time period. That means it depends upon the slowest device. Here also, for transferring the data from one device to another device, the disadvantage is that the timing depends on the particular, the timing depends on the slowest device. Okay, so that is the disadvantage. But as you are using a synchronous bus, it is very easy to program. Okay, otherwise, if no timing is related, it is very difficult. Okay, so circuit in case of the synchronous bus is simple. Okay, but if it is an asynchronous bus, that means no timing is related, one device can send the data at any time. That type of circuit is a little bit difficult. Clear? So this is the asynchronous bus. Asynchronous bus means each data item is accompanied by a control signal that indicates is present to the destination unit. In the previous case, there is no additional control signal is required for transferring the data from one device to another device. But in this case, one or two additional control signal is required. The presence of the control signal means that data is in with the device, or data is sent by the device, or device is sending the data, or device is receiving the data. This type of signal is generated by the one type of particular type of special control signal. So always remember, asynchronous bus transfer is related with the presence of a special type of signal. Okay, so when there is a two, suppose so there are two devices, one device is sending data to the another device, it will send the data along with a particular control signal and tell the destination device that, see, I am sending the data, so there is a data request signal. Okay, there is a destination can also respond to the particular signal using some acknowledgement signal. It will be clear if I give one example. So data transfer rate varies with the inherent speed of the communication device. Here, one particular device don't have to wait. Okay, because no clock is related with that. It sends the signal and it can do another one. So this is little bit faster. The process is faster and no clock is related. So there is a flexibility in the system. But the problem is this type of circuit is complex because here you are sending the data along with the different types of signals. Okay, what are the signals? It will be clear if I give one example. So circuit is complex, but flexibility is achieved. What I have already told. So you know that I have already told there is a master-slave relation in transmitting data from one device to another. Master can initiate selection of a unit. That means suppose CPU is a master, CPU can select that this IO device requires data, so it puts the particular, last day I have told, particular address and the data count. So CPU is here in this case the master. When DMA is transferring the data, DMA is the master. So CPU can initiate selection of an unit. Okay. Now, an unit can request to the master for access of the shared bus. That you already know that when there is a requirement of transferring the data, there is a DMA request comes and DMA tells the CPU that please leave the bus for me so that I can transfer. So in this case, particular IO device is the slave. Clear? So this is the technique for selecting the particular image. Now, this is the example of synchronous data transfer. This is a read operation. See, as the transfer is synchronous, that means the synchronous data transfer. So it is always related with a clock. That means this is the clock and this is the time period. Within this time period, processor can initiate one operation. Okay. So here, suppose master wants to read the particular data from slave. Clear? So first, master in this time period, within this time period, give the address of the particular device. Okay, this comes from master. Okay, then it will give one signal, that read signal. That means read the data which is stored in the particular address. This is given by the master. See, here clock is related. Okay, so in the next clock cycle, from slave, data will be high. That means data will provide the slave will provide the data in the next clock cycle, and there is option that it change the status. The status from the slave will be changed. That means this status is high means see, I have provided the data. Slave is telling that see, I have provided the data. You can read the data. Okay. Slave is giving this information to the master. Again, I am telling master wants to read the data. So it first, in the first time period, it gives the address along with the read signal. This comes from master. And in the next time period, as this is a synchronous, one clock is related. So in the same time period, it cannot do, it have to go for the next period. So in the next period, slave will make the data line high. That means it will put the data in the bus, and along with it also make the status signal high. That means it will tell the master that see, I have put the data into the bus. So this is the read operation using the synchronous data transfer. Now this is a write operation in the synchronous data transfer mode. See what happens in the write operation. In the write operation, same clock is related with the system as this is a synchronous data transfer. So this is the T is the time period. So here master wants to write some data to particular device. So what will happen? First, the address will be generated from the master in the first time period along with the write signal from the master. Clear? And after the generation of these two time signal, when the device is ready, in the next time period from the master, data will be given. These data will be written to the particular address in the slave. So it all comes from the master, from master, from master, from master. In the previous case, this one is from slave because that was the read operation. As this is a write operation, this data also comes from the master. Master will give the data and will give the address and give the write signal. That means the data should be written to the particular IO device or memory location, and signal is right. That means it should be written. Okay. And after in the second time period, this is the first time period. In the second time period or the next time period, the data will be given by the master. That means the data which have to be written into the particular device. Clear? So this is the synchronous data transfer in the write operation. Synchronous data transfer for write operation. Clear? Here clock is related. So these are the two examples for synchronous data transfer. Now we will learn about we will see that what is asynchronous data transfer. Asynchronous means I have already told you that in the asynchronous data transfer, no clock is related. This is the clockless. One particular data is connected with a particular signal. Okay, and this signal may come from the source, and destination also sends some signal that is called the acknowledgement signal. So one, in the asynchronous data transfer, the data is related or accompanied by a special type of signal, and there is no clock related with the asynchronous data transfer. So asynchronous data transfer, there may be two types of asynchronous data transfer. One is called the one-way control. That means one of the two communicating devices supplies the all control signal. I have already told that asynchronous data transfer is related with a particular special type of control signal. So this control signal may be generated either of the device. That means it may be generated by the source, it may be generated by the destination. Okay. So if either source or destination generates the control signal, that is called one-way control. And if both source and destination generates the signal, then that is called two-way or interlocked asynchronous data transfer. So asynchronous data transfer, there are two types of asynchronous data transfer. One is called the one-way control and another is called the two-way control or interlocked. In the one-way control, the accompanied signal is generated by one of the device, and in the two-way control, both the connecting device will generate the control signal. Okay, so it will be clear from here. So this is a one-way control. See, in the one-way control, a single signal controls each address or data transfer. There is only one signal for controlling the data or address transfer. This signal can be activated by the source or destination. That I have already told. Either of them can be the busmaster. If this is activated by the source is the busmaster. If the signal is activated by the destination is the busmaster. Okay, and all other components of the cells. So this is the one-way control. It will be clear from this figure. See here, there are one-way asynchronous data transfer. Here, this is A is the source initiated. That means here source is the master. B is the destination initiated. That means here destination is the master. So if source is the master, source wants to transmit the data from source to destination. First, it will put the data line high. This control signal high. That means it will tell the destination, see, I have put the data onto the bus, in the bus. After some time, this is the starting time of the data. After some time, it will make the control signal data ready high. That means it will give the signal to the source, see, the data is ready and it is already given into the particular bus, data bus. Okay. First, it will start the data, then it will give the signal and it will tell the destination that see already data is present into the bus. So this is called the source initiated. Another is called the destination initiated. Here destination is the master. It can initiate the transfer of the data. So as destination is initiated the transfer of the data, as this is the destination, first destination will request the data. Clear? So it will request the data. After some time, source will make the data high. So this data line is high. This is made by the source. So here first data request will come. After some time, the data will be high. That means data is available in the data bus. So this is the destination initiated data transfer. Now in both the cases, one thing is common, that no clock is related with the system. In the previous case, you know that one clock is related. See in the previous example, if I go here, see one clock is related and time period is given. Data and address is given one time period, and destination next data is address and write operation is given one time period, and data is available in the next time period. So one clock is there. But see here, in the case of the asynchronous data transfer, one-way data transfer, there is no clock. Only this data and this signal. If this is a source is the master, and if destination is the master, So this data and this control signal is the data request. So this is one-way asynchronous data transfer. Now the problem with the one-way asynchronous data transfer is that if data is transferring from the source or destination, source do not know whether the data has reached the particular destination or not. Clear? Because this is asynchronous, no time is related. In the previous case, there is a time bound. After that time, if it stays, if data does not reach there, that means the data transmission is not successful. But here it is difficult because this is asynchronous, no time is related. It can reach after 5 seconds or it can reach after 6 seconds. So how source or destination will know, or another device will know that data has reached to the particular device or not? Okay, so for this reason, there is a requirement of two-way asynchronous data transfer. What happens in the two-way asynchronous data transfer? In the two-way data asynchronous data transfer, when source sends the data, first source sends the data along with the signal. Okay, after reaching the data to the particular destination will send another acknowledgement signal. The meaning of the acknowledgement signal is, see, the data has, I have got the data and it is okay, and data transmitter has been completed. So it will send one acknowledgement signal. Clear? So if I go to the particular example, it will be easy to understand. See here, first one is the same thing, but this is a two-way communication. Okay, so two-way asynchronous data transfer. First is the source initiated, A is the source initiated, and B is the destination initiated. What happens in the source initiated? First, source makes the data line high. Clear? Then after some time, it will make the data ready high, just like the one-way communication. So when it reaches the destination, okay, destination will make this acknowledgement signal high. Acknowledgement signal means it will tell the source that, see, I have got all the data and data transmission is completed. When this acknowledgement signal reaches to the source, source then make this data line low and data ready line low. So first this, then this, from this here it comes, from this here it comes, that means it makes the data ready low, from this it makes the acknowledgement signal low. This is the source initiated. Similarly, B is the destination initiated two-way asynchronous data transfer. What happens in the destination initiated? In the destination initiated, first destination will give the data request. Clear? Make the data request line high. So destination is making the data request line high. So now source will give the acknowledgement signal. Clear? So it will give the acknowledgement signal. First it will put the data into the line. Okay, first it will put the data into the bus. Then it will make the acknowledgement signal high. That means it will tell the source that, see, I have given the data and I have made it a high. So now data will be transferred from source to destination, and after that, when this acknowledgement signal now it is given by the source, when it reaches the destination, it makes the data request line low, and it will be low, and data line will be also low. Clear? So this is called the destination initiated asynchronous data transfer. So what we have learned? We have learned that bus can be controlled in two ways. One is there is a two types of bus. Bus can be controlled by the slave and master in a particular machine or system. One particular device can be master and another is the slave. There are the two types of transferring the data in a bus. One is called the synchronous, another is the asynchronous. Synchronous related with the clock. The circuit is easy, but this is not flexible. And asynchronous means there is no clock is related. The circuit is complex, but flexibility is high. In the asynchronous, there are two types. One is called the two-way, and another is called the one-way data asynchronous data transfer. In the one-way asynchronous data transfer, only the particular control signal is related, and from the particular destination, no control or source, no another control signal or acknowledgement signal is generated. In the two-way, there is another signal that is called the acknowledgement signal is generated. The meaning of the acknowledgement signal that yes, the data transmission has been completed successfully. Yeah, so this is called the two-way asynchronous data transfer. So this is, thank you.